Okay, welcome to our second video on the series of magnetic method, and we are going to continue on the half-width method. Now, the half-width method, sometimes it's dependent on the kind of residual anomaly, and residual anomaly shape is dependent on the latitude where you took your reading. That's why if you are in like Nigeria, for example, there's a way your latitude anomaly will look like. If you are in California, there's a way it look like. So it's more of something like this. This one is more inclined to 0 degree latitude. Okay, so from like this, it will start moving up. There are ones like this, so it's more of 45, 45, like that. It's be increasing like that, increasing like that, increasing like that. Okay, so that's that on when you're talking about the residual anomaly dependent on the location of the anomaly. So different reading taken in different places, even if you have the same data, you cannot have the same data actually, but depending on the location where you took there's a kind of residual anomaly that is specific to a particular latitude area on the Earth's surface, anywhere you find yourself. So now, for half-width method, when we have something looking like this, where we have, let's say our data look like this. Can you see? Okay, it looks like this, right? If you look at this now, you know that this latitude is tending towards the negative side, not 0 degree, more in the negative region. So now, if you're looking for half width for something like this, it's not really like the first one. So, but it's still the same way. You first find your half amplitude, right? So let's just try something. Let's say here is 20 plus 20, and here is minus 100. Let's just say 20 minus 100. Let's say 10. Okay, let's say here is 10, 20 minus 30, minus 10, minus 20, minus 30, minus 40, minus 50. Let me use minus 60. Okay, minus 60. Good, right? Okay. Now, for this kind of residual anomaly, you want to look for find the half-width method for something like this. It's kind of easy. So what you just do, you just first find the half amplitude first. What location of this anomaly? And I tell you that half of the amplitude of this guy is giving us peak, which is the highest reading, minus the lowest over 2. So the peak, positive digit at least higher than negative digit. So the peak is 20, right? Minus the lowest. What's the lowest? Minus what? Minus 60. Everything over what? 2, right? All this gives us 20 plus 60 over 2, and that's what? 80 divided by 2, and that's what? 40. Good. That's half amplitude at 40. Now, the mistake that most people will do is that when they get this half amplitude, they're always thinking that they'll just go to the place of 40. It's because the first one, like it started from 0 to this place. That is why you can easily locate it. Let's say the half amplitude is 50, for example. Now you can easily go to minus 50 now and just do like this. Half amplitude 50, because it starts from 0. So you're starting from the peak. So because our calculation is from the peak, we'll count downward to 50. So this one too, from the peak here 20, we're going to count 40 from the peak. So going to 40 here is wrong. That is not where your half amplitude is. You come here from the peak, which is the max, right? Which is at 20, right? So from here to here is what? 20. You want to calculate 40, abi, from the peak. From here to here is what? 20. From here to here is also what? 20. So this is where we have our what? Half amplitude. Good. Now we have our half amplitude. So for us to get our x half straight, for this kind of data, we don't really stress. There's an easy way of getting our x half. easily. So the point where you have your peak of your amplitude, you rule a straight line at that point. Then the point where you cut, can you see on this guy? You rule a straight line, like you trace that point. Use a ruler, you trace it up. Can you see? So a distance from here to here is our what? Is our x half. Straight. You don't need to do x2 minus x1. That's an easier method of doing x half on this axis. So you just count. Okay? You just count. So now how do we count? Very easy. If you have boxes, your graphs include boxes like this, right? And you know what each increment means. So the first line, you take it as your zero. The first line is your zero. You know that each increment, for example, now this one is 10, 20, Abi. So you know that each increment will be like 1, 1, 1, 1, 1, for example. So from year to year is what? 1, 2, 3, 4, 5. You must take the first line as 0. So you know that if from year to year is what you're calculating as the x half, your x half here will turn to what? 5. So here lies now, let's say what we are calculating, let's say our lines are like this, 1, 2, and 3. So your x half here will be what? 3. Good. So the theory still remains the same. Even if you have your, just depend on the geometry you are going to use. The geometry of this anomaly that you assume for this anomaly is probably a vertical cylinder, which is z. That's for finding the depth. If z is equals to 1.3 x half, let's say we assume that what is we have in this geometry is like a vertical cylinder. Let's say what we have here is a vertical cylinder, for example. And the geometry for a vertical cylinder, z is equal to 1.3, which is the depth. We are going to find that magnetic or metallic ore. Let's say magnetic to metallic or no magnetic ore. So you just multiply it by your x half that we got here, which is 1.3 times 3, and that is 3.9 meter. So that's how to get your half width method. We've come to the end of our video. Thank you very much.